Hi, this is Scott from fairlynerdy.com. In this video, we'll show how to make your own z-table or normal curve in Excel. You can use this so you don't have to look up the table. You don't have to try to copy it off of something you see on the internet. And you can actually put it into Excel and do things like interpolation. So it's fairly easy to do. The first thing you want to do is make your rows and columns for the z-table. So here, I started with 0 and went up to 3.5 standard deviations. So I started, just put in 0.0. Then this cell is 1/10, 0.1 bigger than the one above it, and you can just pull that down. Then on going across the top, start with 0.00, and each cell is 0.01 bigger than the one to the left. And this would be a standard z-table, so you could read this and saying that this value here is 0.40 and this value here is 0.49. I went down to 3.5 standard deviations or 3.49, but you can go to whatever you want. And then the function you want is going to be NORM.S.DIST. So if I delete these, I can go equals norm for normal dot s because you're going to put in the z value, and dot distribution. You add the two cells that you want. So here I'll go. My z value is C8 plus D7. I'm going to press F4 to put this $sign in front of the C because I want to make sure it stays on that row, and I'm going to press F4 to put the $sign in front of the 7 here because I want to make sure it stays on this. It stays on row 7 and column C. And oops, I need another argument. I need cumulative. I need true for cumulative. That's what I want. That's what a standard z-table is, true, cumulative. So now you can pull that down and across, and you have the table. You could do that the whole thing. I actually put a space, an empty row every 5 rows because that's what the standard z-table looks like, just to make it a little easier to read. And this is your standard z-table that you find on Excel. If you want to make this kind of normal curve, you could do something slightly different. Here, once again, I have a z value. Start at negative 3.4, but you can start at whatever. Each row is 0.01 greater than the one above it, and I just pulled that down until I got to positive 3.4 here. This cumulative probability is the same as the z-table above. So if I go to 0 here, you can see it's 0.5, and these columns are effectively just the z-table in column format, which is pretty useful if you want to do interpolation or say a V lookup, a vertical lookup. And if you plotted that, you would get this cumulative probability, and that's what this z-table kind of square chart comes out to be if you were to plot it. But if you want the actual normal curve, you need probability density. So here, once again, it's just normal dot s dot distribution, and then your cell, and then false because we don't want cumulative. We want the probability density, so we go false. And if you pull that down and plot it, you get a normal curve. So the normal curve is useful if you want to plot against, something else that you have and see how it falls against a normalized curve. All right, well, thanks for listening. If you want to, I've done a lot of work to put all of my z-tests and t-tests into one cheat sheet that you can use, that you can reference if you're doing hypothesis testing. That has what the purpose and an example, and then the equation for each of these hypothesis tests and how you do it in Excel. If you want to get that for free, you can go to fairlynerdy.com, hypothesis testing cheat sheets. And I'll put this link in the description at the bottom of this video. Thank you.